Hi folks, we're going to solve here 11C from the Unit 6 Lesson 4 worksheet. So they're asking us to factor this expression. The first thing I notice is that there's 4 terms here. So I should be thinking about grouping some terms together. I notice that there's no cube term because one of our grouping techniques is to take the first two and the last two, but that really works when there's a cube, a square, an x term, and then a constant, which is not what we have. All right. Now there's another grouping technique we saw, and I want you to focus your attention on that last term. Okay, minus 4z squared. Now not only do I have a subtraction here, but I have the subtraction of a perfect square. This is just 2z all squared. So what I'm going to do is I'm going to focus now on those first 3 terms, because if I can show that the first 3 terms also form a perfect square, then I'll have a difference of squares. All right, so let's work on that here. And this looks very promising because 4x squared is a perfect square. It's just 2x all squared. And 9y squared is also a perfect square. All right, it's just the square of 3y. And since my middle term is being added, I expect to have an addition there. So let's see if this works. Let's see if this is indeed a perfect square. So remember what the trick is here. It's squaring the first, so 2x gives you 4x squared, great. Squaring the last, 3y squared is 9y squared, and it's supposed to be twice the product of first and last. Well, let's find the product of first and last. It's 6xy, so 2 times 6xy is 12xy. So this is indeed a perfect square. All right, and then I have the subtraction of this other perfect square, which is 2z all squared, and now I have a difference of squares. So in other words, I have a squared minus b squared, which of course factors to the first plus the second times the first minus the second. And so now I can just go ahead and apply that rule. Okay, so the first is 2x plus 3y, then plus 2z, and then the second one will be 2x plus 3y minus the second, so minus 2z. And there you have it, your factorization, okay, in this case here, into 2 trinomials. So just to recap here, how do you recognize this? Well, first of all, you see that there's 4 terms, so you should be looking for some sort of grouping. The fact that there isn't a cube, a square, an x, and just a number tells you that it's not going to be the first 2 and last 2. But the fact that this last term is subtracting a perfect square tells you that you're probably going to be grouping these first 3 terms, and in the end, it does work out. All right, so that's it for this one.